Okay, let's get her started. We are doing 5.4 and 5.5 today. 5.4 is on dependent events. And we'll see how it's related to the independent events we did before. 5.5 is on counting techniques. Anyone in here has anyone ever played Texas Hold'em? Alright, so if you play Texas Hold'em, this is gonna make sense to you. If it doesn't, I'm going to explain what happened. Texas Hold'em. The poker game. You get two cards face down. These are called your pocket cards. And they're yours alone. And then you will, over the course of the rest of the game. Get 5 face-up cards that everybody gets to use to make the poker game. So you know, alright. So the best 2 pocket cards you can have. Best pocket hand in the get-go. It doesn't always win. But the best pocket hand is a pair of aces, 2 aces. So let's compute the probability of getting a pair of aces. We're gonna have the probability that the first card equals an ace. And second card equals ace. What did Anne do in the independent section? And remember what the Anne turned into? Addition. Yeah, sure. If it's an subtraction, is really just adding a negative, so if it's not addition, it's not subtraction. You're along the right lines, though. What else we got? The or turned into addition, the and turned into multiplication. But the second card equaling ace is it's dependent on something, right? It depends on the first card being an ace. This first one here is always 4 out of 52. There's 4 aces out of 52 cards. This one could have gone 2 ways. If the first card is not an ace. Then there would be 4 cards left, or 4 aces left. Out of 51 cards. We already drew one of the cards. But if the first card is an ace. Now there's only 3 aces left. Out of 51 cards. This depends on what happens in the first card. Well, we've already declared what the first card is, so we get to choose. This one forces us to choose that set. So our multiplication is going to be 3 times 51. And believe it or not, this one reduces to 1 out of 13. This one reduces to 1 out of 17. And you multiply them, you get 1 out of 221. Which means if we look at that law of averages we were talking about, on average. One hand out of every 221 hands. Will be a pair of aces. They're also called pocket rockets. Because the A looks like the tip of a rocket. There's your gambler terminology for you, learn something every day. I just call them bad luck. I don't win very often with them, they should win more often than they do. I used to play with my wife's family and her cousin Rhonda would just play any two cards. It didn't matter how much you bet pre-flop. You could push all in and she would fucking call with like 2-8 offsuit. She fucking got lucky more often than it's fucking right. Fair. Right, she'd call like with crap cards, you don't play poker. 2 and an 8 with different suits is like one of the worst hands you get, 2 and a 7 is actually the worst. You can't make it straight and it's hard to make it flush. Those are 2 of the better poker hands. You can't make either of them without having most of the cards on the board. But she would still fucking manage to win. This has another notation. So I said probability the second card equals an ace depending on if the first card equals an ace. The way they would write this is probability is first equals an ace times the probability that the second equals an ace, and then they do a vertical line and say first equals ace. And this vertical line right here. Kind of is substitutes for, given that the. Or depends on. So this is second card equals an ace. Given that the first card was an ace. If I use 2 letters rather than aces, because that's just very particular to poker. We have 2 events, E and F. Well, we started off with the probability of the first equaling an ace and the second equaling an ace, right? This is the probability of E and F. First equals ace and second equals ace. That equals the probability that the first card is an ace, or probability of E. Times the probability of F with the vertical line E. And generally, we just shorten this to F given E. The probability of F given E. And if I solve for probability of F given E, if I divide both sides by P of E. I get the probability of F given E equals the probability of E and F over the probability of E. Now sometimes, wait a second, give me a chance to write that. I had fun last week about telling people that I went home and asked who was on the chest and you started kind of.
Tell everybody that I flashed.
You started just flashing me. You did start pulling me, you didn't flash me, I didn't actually say flash me. But I said you started pulling her top down to show her chest.
I thought you were talking about my chest.
I know you did, yeah, otherwise there's no other reason to pull down your shirt. No shame in Val's game. Now, if you don't have the probabilities already, this sucks, cause you have to calculate it. Oftentimes, you just have the number of times those things happen. So there's another variant of this with N. E and F. Over N with E. So the P is probability. But the N here is the number of events. Or number of options that work. In terms of stuff where you collected data by doing an experiment, it's the number of times an outcome happened. Let's wrap this up into two things for you. So we have probability of E and F. Equals probability E times the probability of F given E. And this was for dependent events. Does anyone remember what we had for independent events? Like, what does probability E and F equal with independent events? We did this last week. Someone write it down? Anyone take notes? Here's your chance to show that you took notes and skim backwards.
There's no probability.
What it is,
It's
but
under my notes.
there's an actual equation we have.
Oh, P is the probability of E and F equal to probability of E times probability of F.
There we go. Arturo wins. Y'all are slow. Slower than Arturo at least. That's word boxing. Let's put a box around both of these. Cause that's really the only difference in those two setups. Usually when we're doing events with E and F, with two different events, we wanna see if they happen, we really need to know if they're independent or not. This actually gives us something neat. This gives us a way to test for independence.
They have some of this on when you did 5.3, but some of this.
This line right here was 5.3. That was in 5.3.
Okay, yeah, cause I remember.
That's why I was saying,
But so the next section we're doing is the dependent. And
this
that's
one
what-
up here was 5.4.
Got it, okay.
I'm just trying to make connections to previous topics. Val, one of these days, the faces she makes while she's fucking. If you can't see well, scoot your ass up front. Or get better glasses, working in an optometrist shop. This is
No, I know, right? It looks bad for business.
Right? Red is bad for business. I'm gonna call your boss. She's so against like getting new glasses that she'd rather squint and make grandma faces. Grandma trying to figure out how the laptop works.
That's how I feel when I'm doing my homework. I cried yesterday.
Right?
Yeah.
Was it over homework?
Yeah, because I didn't understand. It's pissing me off.
Oh, that sucks.
Little-
Did you use Ask My Instructor?
I'm sorry.
Did you do the Ask My Instructor? Cause I don't recall getting any email from Val.
No, I just cried like a. That's what I did.
So if you get stuck and you're getting frustrated, use the Ask My Instructor. I can't help you if I don't know there's a problem. And crying about it to me the next day with no numbers and no questions isn't gonna help you. I am humored by the crying like a little bitch thing, but
Well, I eventually figured it out, I just had pressures, that's how it went,
that helps.
yeah.
Sometimes getting a good, like. Getting over the frustration, like maybe I can actually figure this out, I gotta stop and think and maybe look over my nose, do some shit, I'll
I
just.
talked about 3, chapter 3.
Yeah, that was tough.
Don't worry, you're gonna keep feeling that way, cause this class is a word problem class, and most people hate word problems. And most people blame it on math.
You know what's crazy too, I did 3.1. And I skipped 3.1, I did 3.2 or 3. Before I seen that there was 3.1. I did 49 questions before I did 33. And I was like, fuck, I'm actually behind 2 segments.
Oh, no.
And then my fucking thing expired too, so,
Yeah, I know you're getting it soon,
I
but
cried too, and good.
yeah, I just gave up, I said, fuck this, and closed it.
right? Then he emailed me and cried like a little bitch.
Yeah.
I just did it to on my couch.
That was Val's words, I would never say that about her,
Yeah.
but that's how she references any letdown. Alright, so. I said this gives us a way to test for independence. And it does. Means. Test for independence. The only difference between those two equations. Was this bit right here. So probability of F given E. Equals the probability of F. Then F and E are independent. Because it means. E isn't affecting the probability of F. Yeah. More often than not. You're not gonna wanna, you combining the probability of F given E. If you're doing all that, you probably already know whether it's dependent or independent. This is only really helpful if you have like the results already and you know what they are. And you can match out, well, does. Does the probability of F given E equal the probability of F? Well, let's start with one that has the number version. So first question. In 2005. 19.1% of all murder victims. Were 20 to 24 years old. I'm gonna say Y dot O dot. 1 to 24 years old. It's also known that 16.6%. Of all murder victims. Were male. 20 to 24 years old. What is the probability? That a randomly selected murder victim. This is pretty dark. Was male. Let me, hold on, we have that, a randomly selected murder victim. In the 20 to 24-year-old category. Was male. Okay, so in this case. Let's see, let's write down the equation we had and see what we can put in. Probability of E and F. Equals probability of E. Times the probability of F given E. Let's see what we can match up with what.
And this is how you do it with the homework, like. Look, when you're doing the homework, this is what you be doing too. Alright, cool. Telling you, sometimes I like take the notes and I'm like, what does this even connect to the notes?
So. In the interactive ones, like the, in like 5.1, 5.2. They do, they're walking through another type of lecture, basically. Where you interact with it and they'll explain shit in different ways.
Okay.
When you actually do the chapter number review problem, like chapter 5 review problems. It's all a bunch of problems without them prompting you for shit. And like I pull like examples from those and put them in these. So like these are pulled from examples. So let's like write what we know. I know the probability. We're talking about murder victims for all of it, so like the murder victim part doesn't really help. I've got two groups that we're looking at, two groups. We're looking at 20 to 24-year-olds. And 20 to 24-year-old males. So let's just say one of them is E and one of them is F. Make the simpler one E. We're gonna say E is 20 to 24 years old. And we say F is male. That's really the breakdown here. A 20 to 24-year-old male is both 20 to 24 years old and also male, so that'll be our other category. Which means this is gonna be the probability of 20 to 24 years old. And we've got probability here. Times the probability, the way it's written here, if I match everything up, F was the M, male. Given that they were 20 to 24 years old. Everybody blames the math or word problems, they say it's the math is the hardest shit. Generally, when you get to the math point of it, it's the fucking, that's the easy part, that's calculator work. The hard part's the fucking English. Everybody blames it on math. They don't like math because there's word problems. Well, it's the fucking English that doesn't work. Hate on English. Do we have information that lines up with any of these from the paragraph that we were given?
Yeah,
What?
16.6% were males, were male victims.
Were male victims in the 2024? That's this group right here, right? That's the 16.6%. Now, you're supposed to turn it into a decimal. By shifting by 2 decimal places. But when it turns out if you keep them both in percents, it's not gonna matter, the end math's gonna get you the same thing. What else do we know? What's the 19.1% relate to? What?
It's all the murder victims, not just now.
All the murder victims, so that's like this group right here, right? That's the 19.1%. Does this line up with what we want? That would be this last sentence here. What is the probability that a randomly selected murder victim in the 20 to 24-year-old group was male? So the way that sentence reads is, we know the Vic was 20 to 24 years old. Were they male? So the Vic being 20 to 24 years old, that's a given piece of information. That's given. And this is what we want, that does line up. Given. Want. Or the criteria. So that is what we want, so. I'm gonna simplify that a little bit, would be 0.191. So if I write this without all the jargon there, I've got 0.166 equals 0.191. And I'm just gonna write times P of F given E. I don't wanna write out the male and female or male and 20, 24-year-old shit if I don't have to. To find the probability of F given E, we just divide both sides by 0.191. So we are gonna get. Probability of a male given 20 to 24 years old. Is 0.166 over 0.191. And I'm getting 0.869. Now, I don't know if that's all that helpful for you. That's hard to read for most people. We started with percentages, why don't we switch that back to a percentage? Move the percentage right twice and we get 86.9%. If the victim was 20 to 24 years old, the probability of it being a male is 86.9%. Back in 2005, I don't know if it's different nowadays. Give me a moment to think about that, we'll do another problem, but I'm gonna ask a follow-up question to this. Something that I think you're gonna find helpful. What happens if I fuck up? This can have a couple of ways. Either you don't put that in the calculator, right? If I did 0.191 divided by 0.166 in the calculator. The correct is this. 0.166 divided by 0.191. The top divided by bottom. But if you fuck it up by doing this, or maybe mislabel these. What do I get if I do that in a calculator? 0.191 divided by 0.166. I get the probability of F given E. Equals 1.15. When we started talking about probability, there was only a couple of requirements for probability. And one of the requirements probability. Any probability has to be between 0 and 1. This. Well, if I go the other way. This doesn't meet the criteria. Which tells me immediately. I did something wrong. If you get a probability over 1. It's wrong. There's no situation. Where a probability above 1 works. Ever. If you got 1.2, if you've got 1.001, if you've got 10, if you got a number bigger than 1. You did something wrong. Now, it could have been just entering it in the calculator wrong, it could have been you set up something wrong, but it is a big red flag, something's wrong. Okay? That's a pro tip for the test. Pro tip for midterm. There are probability questions on there. If you get a probability greater than 1. You're wrong. You don't even need to wait to see what the computer says. And you're gonna get marked wrong. Because there's no chance it's correct. So if you get that, go back and look like you got fucked up. Go back and find it if you got 9. Let's look at another type of scenario. I said we could also do with those stuff with ends rather than probabilities. Let's take a look at a situation that has that. So. A survey was conducted about faith. Are you a non-believer or an atheist? Did you believe in the one God? Or Christian God? It was probably done in America, so it was probably Christian. But I don't know that it was specified, it might have just said God. Or do you believe in a universal spirit? You're not so big on like. A human personification of some great power. You just think there's a universal spirit or something that guides it. And they recorded the answer by region. So I'm gonna make a table. And in the region column, we're gonna have east. This feels like an odd way to break it up. But they had east, midwest, south, and west. And we have God, spirit, and east, or atheist. I'll write down the number of people that responded in each category, grouped by where they were. Start filling in numbers and give you a chance to catch up. And if you add these up, I'll do like a total column for both, this you might find this helpful. This is 255. 254 in that row, 254 in that row. 254 in that row. This was 787. 167 and 63. That would be the overall. Now, I don't know how long ago the survey was conducted, because I think atheism has been on the rise. Us heathens, us non-believers are growing. Sometimes people switch between categories. I used to be in the God category and now I'm in the atheist category, and some people go the other way. It's usually the other way. Cause you start off atheist, you're not born knowing a God. That's, you don't know, if you don't, you've never learned about it, how can you follow it? So here's a fun fact about the cupcakes. I took them home and I didn't tell my wife they were mocha. And so she had one. She didn't even realize that it fucking spelled out anything until she fucked up the frosting on one of them. She immediately pulled one out and just bit into it, not waiting for fucking dinner. And afterwards, I'm like, well, how was it? And she goes, tasted well, fun. I'm like, what? That was pretty good. Something's wrong. Something's wrong. And I'm like, well, why? What was it? Like, she's like, it tastes like chocolate. Like, oh, that's my. I didn't tell her they were mocha cupcakes. Like, I didn't tell her it was a coffee flavored frosting. So like, she was expecting the taste of chocolate and it was not the taste of chocolate on the frosting. So, yeah, it tastes like something was wrong. As soon as I said it, no, those are mocha, she went and grabbed another cupcake. And the second cupcake, with knowing what it was, that was pretty good. Really, what you think you're getting really affects what happens. Very much. I know that applied when I was a kid. Me and my brother, when we were like, I was probably 9, he was 8. They knew we didn't like fish, or we would not, we were okay with fish, like we had tuna fish and we'd eat it and we liked it. So they made squid, calamari, and they told us it was called Alaskan whitefish. So it was a fish, like we ate in it and we went and got seconds, we liked it, it's good. We got seconds, and after we ate our seconds, they told us what whitefish really was. And like the children that we were, we went, that's gross. And like, you went and got more. You can't fucking say you didn't like it if you went and got more. Right?
My family did that to me when I can't have my mom like
You can't have it?
that CBN, so
Ah,
it's
man,
the only seafood I like.
can you make a fried casing on it that doesn't have gluten in it?
I wanted to, but
Right. Either watermelon seed flour, that sounds fucking disgusting. I saw that the other day on the phone, did I tell you guys about it in here? Might have been in the other class. There's a cookie out now. It's like a honey cinnamon cookie that's made with watermelon seed flour. Which means they must have strained out all the fucking watermelon seeds. Which are almost smaller than sunflower seeds. And then ground those motherfuckers up. You know how many watermelon seeds you'd have to grind up to get enough flour to fucking make something? It doesn't even fucking sound good. But it's gluten free. Alright, so my questions for you, you should have had enough time to write this shit down. We're gonna do 2 questions. Probability of someone who lives in the West is an atheist. And the second one we're gonna do is probability. That should say not on, probably probability of someone who is an atheist lives in the west? Got all the same words, doesn't it? The first sentence has exactly the same words as the second sentence. But they are in a different order. And order matters. So whatever's coming first. This is like our given piece of information. It's our E. So this is asking for probability of an atheist. Given that they live in the West. And this is asking for the probability that someone lives in the West. Given that they are an atheist. Now, we had two versions of this. We could do. Probability of E and F. Over probability of E. Or we could do numbers in E and F. Over numbers in E. Seeing as how we don't have probabilities already. Don't switch to probabilities first. So we're gonna use the number. Number of people that are both atheist and West. The ampersand means and. Over number of West. And this is gonna be number of atheists and West as well. Because the and works both ways. But this is over the number of atheists, the given information. Okay, so I can pull that from the table. How many people are both atheist and West? 26, right? It's that square right there. Both of these have that. I'm gonna write it in both. How many people live in the West? 254. How many people are atheists? 63. So we can turn these into a decimal. And I am getting approximately, I'll go 4 decimal places. They like to do a lot of decimal places. If you round appropriately, you get 4. And if I do the 26 divided by 63. I get to 4 decimal places, 4127. And I don't know about you, but I don't like looking at decimals when I'm talking about probability. So I'm gonna move the decimal point right twice and call it percent. So only about 10% of the people that responded that live in the West were the atheists. Like over in California and that shit, only 10% of them were atheists. But if you did like atheists across the state and like said, where are they mostly at? Most of them are in the west. Where apparently the western side of the US is the heathen side. Go heathens. Could I have gotten this doing probability? Just look at doing one of them, let's do the probability. Of west and east. Or atheist. Sorry, west given atheist. And we're gonna base that off of probability of west and is atheist. Over probability of atheist. Just doing number two the other way.
Said West Any, you said. The second time you said West and East atheist.
Yeah, west given atheist, I fucked it up.
Oh, okay.
I'm rewriting this one, this bottom one, number two, in terms of probability.
I got you.
So the probability that someone lives in the west and is an atheist. There were 26 people out of 1,017. That's the total number of people. And the probability that someone was an atheist was 63 out of 1,017. These are called complex fractions, they kind of suck. But you can multiply, you can get rid of it by taking the bottom fraction. And multiplying the top and bottom by it. And if you do, the stuff on bottom cancels out. And the 1,017s cancel out here, and you get 26 over 63. But let's say you didn't do that, let's say you calculated 26 over 1,017. $388. And the top or bottom is 63 divided by that. And I'm writing down all the decimals because, like, if I round early, it could change the answer. Those are the individual probabilities, and then if I divide those. 0.025565388 divided by 0.061946902. I get 0.14127 again. So I get the same number. That we had right there. But that was a lot more work, right? Just use the numbers. In fact, if you're given a table. The easier way to do it is just block out the shit you don't need. We were looking at this problem, people that are in the atheist category. Block out everything that isn't in the atheist category. And then we're looking at West, which was 26 over the total, which is 63. Or pull them like we did before. No falling asleep. It's okay. I know I'm boring and all, but
No, it's not you.
I didn't think I was, maybe I don't think I'm boring, I think I'm awesome. The fuck was funny about that?
I'm not laughing at that. I was laughing.
Okay,
Guys.
what, you laughing with me, not at me?
Yeah, that.
Yeah, there, okay, good answer. Here's over here, he's trying to lock in that F. Last week he wants me to shit myself, this week he's laughing at me. God damn, boy. Let's take a 10-minute break and we'll do 5.5. Alright, I'm resuming recording.
I didn't even finish my, I didn't even finish.
How long should I give him before I start putting it down?
3 seconds.
See. It made a lot of noise when I started recording, you guys ready? I don't wanna interrupt you guys, like if you got better shit to do than like. Oh, there you go, that was for you, Arturo, I know you like it, you smile, already.
I didn't even hear that one, bro. I'm gonna lie to you. You're good, that was almost normal.
Alright, let's focus. Get this shit done, counting techniques. I don't know if this has changed, this might have changed, but the typical license plate in California. If you don't request your own. the Typical California license plate follows the following sequence. It has a number, it has 3 letters in a row, and then it has 3 numbers. If you just get a random plate, that's how it used to be. I don't know if this has changed, but we're gonna pretend it didn't. This is how it is. How many different combinations are possible? This ends up being a lot like probability. In that. We're doing multiplication. We could list them out, I could have 0, AAA. 0, 0, 0. And I could have 0, AAA, 0, 0, 1. And I could go do this all the way down to 9 and only change the last number. So like the last number, the first 6 being the same, all had a total of 10 different combinations. 0 through 9 is 10 numbers. If I did every combination, you're gonna see that, just like we were able to do with. The different combinations on 2 dice 6. Different combination. Wow, that's not spelled right. Pair of dice. Our total outcomes was always 36 on bottom. It's our total outcomes. That's 6 times 6, it's multiplication. So it's very similar to what's going on with the probability. How many different digits do we have? 0 through 9, you got 1 through 9 is 9, but the 0 makes 10. So each of the ones is a number, it could be a 10. How many different letters do we have? This is not a trick question.
3.
Oh, get the fuck out.
Hey,
26.
My bad, I thought. You said.
The alphabet has 26 letters.
Oh, well. Oh, well.
Yeah, the L's I have are, yeah. Or you could have just said there's one, the L 3 times, right?
Yeah.
So like the number of plates. Is 10 times 26 times 26 times 26 times 10 times 10 times 10. Which means if you multiply that out, I'm assuming what I got in my notes is correct. There's 175,760,000 combinations. Different combinations. Let's say I want plate. 1 DRJ, those are my initials, and let's throw in some 007 because I like being fun. Let's say I wanted that on my license plate and I just want a random chance to happen. What is the probability of that plate happening? Well, there's only one plate like it. And there was 175 million combinations. So. Without throwing this in a calculator, why don't we just go with really fucking low? What if we didn't want any repeats? Oh, slow down. I know, I'm talking about it. I've noticed that my cussing this semester is way less than it was last spring. Which is interesting.
Why do you think that is?
I know it, I know for a fact it is, because like I lost my lecture notes for computer science. So I'm watching all my old videos to go, what the hell did I teach on that day? And I F, I'm like, god damn, Jones, I even for me, I'm like, that's a bit much. So like I cuss occasionally, in there, but like it was a lot. It was bad. Class was entertaining, no one ever said anything.
You need a swear jar,
Oh, hell no, I can't afford a swear jar.
you be rich.
If someone paid me when I swear, yeah. That's not how a swear jar works though. That would be great. I would up my swearing if I got paid for every swear word. So how would this change if we wanted no repeats? Let's reason it out. How many different options do I have for the first number? What? We're just gonna do it one at a time. The first digit, there can only be 10. Let's say I picked the 1. There's 10 digits for the verse. I had the choice of 0 through 9. You're trying to go to jump to the end, and it's not right. There's a process. We can't randomly guess the result here. How many different letters can the first letter be? Chris is in a race to see if she gets it right before anyone else. How many different letters can the second letter be? 25. The D is already taken and I don't want to repeat. So there's only 25 letters left if I've crossed out the D. I didn't get to ask, she's just a cheater.
Told you she was smart.
Alright, someone else. How many different options for the second number? 9. How many different options for the third number? Still no, yeah, 8. There we go, need more participation. I have to bring in a fucking muzzle for her. I'll get in trouble if I muzzle this student. I'm sure that would. She'd probably fucking think it's funny if I came at her with a muzzle. She wouldn't let me put it on her. I bet she'd laugh if I fucking brought one in. How many different options for the last number? 7. It's getting easier, huh? This pattern kind of happens in other stuff that we're gonna do. It's handy to recognize things decrease, they go down. And you don't have to put a lot of thought into it. Now, if you multiply that shit all out. There's only 28,624,000. This entire idea is called the multiplication rule of counting. Like, if we're having a 3-course meal. Let's say we go out to a restaurant, we get appetizers. And they have your main dish. And a dessert. And since every restaurant's different, I'm not gonna put in actual numbers. Let's just say there are P different types of appetizers, Q different types of entrees. And R different types of desserts, these are all numbers. And then the total number of options. is P times Q times R. If I were to draw every single card in a deck. How many different ways? And all 52 cards be dealt. And we'll expedite this process a little bit, but we're gonna do like the first couple cards and reading out what's going on. Chrissy, you get to do the first one. How many different cards can the first card be? There. Arturo, how many different cards do we have for the second card?
51.
See how quickly that picks up? Goes from random guessing to fucking just quickly answering that shit. Who else wants to throw some numbers at me? What's next? What's the third card? 50. Val's sitting there back there quiet. We're gonna make her fucking participate. Val, what's the next number?
49.
That's not too hard, is it? It's following a pattern, right? It keeps going down and it's gonna keep going down until we get down to 7 cards, 6 cards, 5 cards, 4 cards, 3 cards, 2 cards, and finally we're stuck with the last card. There's only 1 card left. Now, how long do you think it would take you to enter this in your calculator? Taking a while to enter this shit in the calculator, right? This shows up in math a lot. They came up with a shortcut for it. So any number that multiplies by itself down to 1, this entire thing, the shorthand notation for it is 52 with an exclamation point. This exclamation point is called the factorial. Now, your calculator might have something that says X question mark. It might have N. You might have a calculator that says PRB and there's a drop down that does it. Like these are options on your calculator, things that might have. If you have one of those calculators that says PRB, when you hit it, you tend to have 3 options there. They will do the N factorial, they will do NCR, and they will do NPR for the PRB. We're gonna actually do talk about all 3 of those right now. If you have a calculator like this, there is an NCR button and an NPR button, but where it is on your calculator, it just all depends. Mine, where are they on mine? Mine has NCR right here. And the bold text above it that you can't see is the NPR. And that is not National Public Radio. So. It's important to know that's how it works. So if I wanted 52 factorial, I'm probably gonna break my computer or calculator if I do it. I don't even it'll go that high. If I do that, it says 52 exclamation point. If I hit equals 8.06 times 10 to the 67. And just show a couple decimal places and what it shows at the end of my calculator. It says there's a little tiny X10 and it says 67 like that.
What does the E mean on the calculator?
E is the same thing as the X10. If your calculator has an E there, it probably says E67. What it means is take the decimal place and move that decimal place, move it right 67 times. Holy shit, right? That's a lot of fucking zeros. That is a lot of zeros. Like $1 trillion. $1 trillion. There's only 15 zeros. Right? Just think about how many zeros, that's a lot, yeah, I'm pressing more now that I fucking said it. Did it again, shit. If it's negative, if it says negative. There's no way it's gonna say like -67, but if it says like. E -12 or times 10 -12, it means move left 12 times. So negative is left. Positive is right, and the number is how many times move the decimal point. This kind of, the negative numbers tend to show up with like really low probability. Or when you're doing shit in chemistry, like Avogadro's number and stuff like that. It's a low number. I don't remember the number, I'm not gonna try to even pretend I remember the number. I just remember it's small. Or is it? Maybe it's big,
I think it's 6.022 times 10 to the 23rd power.
it's
Wow.
big,
That's only because I'm in chemistry, like I think I learned this last week.
it's big, I think you end up dividing by it a lot in a lot of the chemistry, so I know that. The use of it ends up getting small in a lot of stuff. It's the number of. Moles, atoms in a mole, I don't know, but shit, I'm not a chemistry teacher. Alright. So. The one other thing to know about factorial. 1 factorial. Is the same thing as 0 factorial, which equals 1. That's the big one to remember, 1 factorial makes sense, 1 times itself is 1, but you kind of need to know that 0 factorial equals 1. And it's because of the very topic we're covering today. 0 factorial shows up in the equations, and for them to get it to work. 1. Now, what is that NCR and NPR? NCR and NPR. Are related to combinations. And permutations. So the first letter tells you what it is. This is NPR, this is NCR. And there's only one real difference between these. Does the order of selection matter? Let's say we're making a pizza or ordering a pizza. And they have some special on a large 3 topping. What kind of toppings do we have on this? Someone give me a topping.
Mushrooms.
Garlic.
That's really your first fucking choice?
Mushrooms.
Garlic, chicken, bacon.
No.
Yeah, bacon.
We're going with garlic, mushroom and bacon. Those are the first 3 I heard from different people.
Garlic's fucking crazy.
Garlic.
That's-
So this is. Part of. What's wrong with Krista? Or she's the one that said garlic, the first topic she said, gotta have. Survey says #1 answer, garlic. Apparently she's got a fucking fear of vampires. This is something, like garlic, yeah, okay, but.
It's pesto with lots of garlic, chicken, and bacon.
You don't get that.
She goes to Blades, she goes to Blades a lot. She shops at Blades.
Fucking plays over there, right? That is.
Little Caesar.
Most people don't order get pesto on a pizza, unless you go into Blaze or what, biology, they do, they have
Yeah, she gets
pesto.
biology.
That's what I put on it. That's what is the best
What does?
one.
This is yours.
Depends on what you're in the mood for. Most of the times when I think pizza, pesto is not it. Who here thinks of pesto rather than like red sauce when you think pizza?
Fuck no.
Like replacing the red sauce, pesto sauce. Krista, raise your fucking hand, you're the one that said it. I'm not making this up. Does the order that we choose garlic, mushroom, or bacon matter? No. Order does not matter, this is a combination. This is under combinations. All right, let's do one for permutations.
That's fucking crazy, huh?
That's the next level shit.
It really is. Oh, man.
So like, let's say. I pick 3 students at random. In this room. My first pick. Gets an automatic A. My second pick. Gets a B. And my third pick. Gets a C. That will be your minimum score. But you can earn higher, like if you got the C, you could earn higher. Does order matter here? It doesn't matter to me, but it probably very much matters to you. I bet Val is like, pick me, I wanna go first.
You're not lying.
I ain't making this shit up. Here, order matters. And so this is under permutations.
Why does it matter though?
Because if I pick you first, you get an A, and if I pick you second, you get a B. That's a good question, if you didn't understand, don't say my fault or sorry or shit like that when you have a legitimate question. I think the easiest way to remember is think about the pizza thing and like there's a combination pizza. There's no permutation pizza. Like you can order a combination pizza damn near any pizza place. Does Blaze have a combination? It probably doesn't have something just called combination pizza, does it?
Yeah, it does.
Does it?
It has to.
Fuck no.
I don't know, there's a lot of fucking weird names, but I don't know that any of them just say basic combination.
Build your own place.
It's a build your own, but they have some pretty suggestive ones, but they're all funky names. But like everyone's familiar with the idea of a combination pizza and the order you pick toppings doesn't matter on a pizza. Well, that's not true. If you put cheese on first and sauce on last, your pizza's shit.
You did it. Yeah, Chicago.
So then you have another shit on top of the sauce on a deep dish.
Second sauce.
But yeah, that's some good shit. I do like me some pizza.
I'm
Yeah.
hungry.
Did you? Side fact, it is a Tuesday though. On Tuesdays, the Curry Pizza Company, right down here next to the,
I barely seen that shit.
that place, it's. I wanna say it's 40 or 60% off a large on Tuesday nights.
What the? Yeah, they got good wings there.
Yeah, good wings.
Yeah.
Oh my
Their
god.
pizzas are pretty good too, you can get a regular like combination pizza, but they also have a lot of. And I know you would fucking love the shit out of it, Krista, cause there's like a bunch of, there's Indian toppings. So you can get like chicken curry,
Why
you can get
she
chicken
like that?
masala,
Why
so,
Why the fuck is she like that?
Cause she said garlic and pesto.
Garlic is fucking Italian, that's not, or Indian.
It's a spicy
I
flavor.
swear, I
It's
swear.
not spicy, it's not spicy, it's like Ireland spicy.
I got a combination.
Chicken masala is not that spicy. Chicken masala is pretty, they do a,
I don't think
probably not. I don't know that they have a gluten-free crust or not.
You know the United Kingdom, they tuna on their pizza.
that's just wrong.
Look up.
Like canned tuna or are
Yeah,
you talking like fresh
like
tuna?
yeah, like the can, like the packet tuna on the, yeah, like sweet corn. I swear, what the fuck?
That's crazy.
Where?
Over there in the United Kingdom.
That's why we fucking broke off from that country.
Yeah.
One of the many reasons.
Yeah.
That's fucking wrong.
Nope.
They all like to dip their fries in mayo over there too. It's already fucking smud, cooked in grease, do we really need to dip it in oil? Like mayo is literally oil. Do we really need to dip something that was fried in oil, dip it in more oil? It's fucking wrong.
And they live a healthier lifestyle over there too.
Most of their shit is healthier, most of the shit we buy in stores, we have all the preservatives and a bunch of shit, and they like. You look at their ingredients of the cereal, yeah, their coloring is based off like. A fruit product, like if you want blue, you got like blueberry coloring in there and shit. Or from like blueberries. What?
That's
That's how
normal
it
shit.
should be.
That's how it should be, well, like in America, we like shit cheaper,
It's like
so
number
we
two.
like ingest a lot of fucking shit that's bad for us. Alright, so. NCR is combinations. The N. Ooh, I went back too far. I don't wanna say this. N is your number of choices. R is the. Total picks. Or selections. So let's say there was like, I don't know, 18 different toppings to choose from. We chose 3. This would be listed as 18C3. N and R. Now, how you enter in your calculator, they all change. A lot of calculators, to do this in a calculator, I put 18, I hit my NCR button. And then I hit 3 and then I hit equals.
What if you don't have that button on your calculator again? What if I can do it on your iPhone?
You're not using your iPhone on your test.
Oh, yeah, but, yeah, you're right.
So. Your calculator, we have there's a formula for it, like,
Are we gonna get those tests?
yes,
Okay, cool.
if you don't have a calculator, you can come up and borrow mine for a short term, I will have a calculator.
Free of charge.
Yeah, I'm not gonna run it out by the minute.
Yeah, but imagine.
I should, I like how you think. I should just go buy like bucket 10 calculators and rent them out by the minute. I didn't even do it, bye. Arturo and his fucking question. So for me, I get 816. If you do this in your calculator, if you know where your NCR button is, whether it's under PRB or. You should get 816. How does that work? The equation for NCR is n factorial over n minus r factorial times r factorial. So for us, you would do 18 factorial over 18 minus 3 factorial times 3 factorial. And I can actually show you how to make that shit easier. This is just 15, right? 18 minus 3. Without writing this in the calculator, 18 factorial is 18 times 17 times 16 times 15, and I keep going. 15 times 14 times 13. I've got a 15 on bottom, I can stop at 15 factorial. This top part, that is 18 factorial.
Well, can you do that again?
Yeah. So I could write out the whole thing, 18 times 17 times 16 times 15 times 14 times 13 times 12 times 11 times blah 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 times 3 times 2 times 1. Or I can wrap up all of this part here. That is 15 factorial. So if I write the top, choosing to stop where there's a factorial on bottom, those factorials cancel. Okay. Yeah.
I'm getting like, so where did you plug that, where you're just doing the slashes? What are you solving for?
This is the formula,
Yeah,
n is 18 and r is 3.
When you have,
So I'm
okay,
replacing-
18 factorial, okay, and then 15.
To-
when you have fractions, it's the same thing on top and bottom.
Okay.
I think he was wondering where I got the numbers in the first place.
Yeah, I looked down for a second, you were fucking like 4 numbers deep, and I was like, wow,
That's all good. Okay, so you okay now,
yeah,
so the 15 factorial cancels, 3 factorial is literally 3 times 2 times 1. It's just 6. So you could throw that in your calculator, 18 times 17 times 16 divided by 6. And you should get 816. Even if you don't have a factorial button.
okay. Like you just simplified it in a way.
Yeah, that's exactly what it is.
Okay.
Simplified it.
Yeah, I get you.
Look at you with your big math jargon. That's right. Flex that shit. Flex that math muscle. That's how that works. That's how NCR works. Let's talk about NPR and then let's do an NCR that's one I'm particularly fond of. Permutations is where like it matters. How many people we got in here? 1, 4, 8, 10, 12, 14. Well, I fucking already fucked up the count. 12, 14, 16, 17, 18, 19, 20, 21, 22. 22 students in here, and I said I was giving out 3. So my permutation example before. Where order mattered, the A, B, and the C grade. My N was 22 students. And my R is I'm giving out grades to 3 students. I'm not really, don't get all excited. Right? This would be 22P3. The formula for NPR is n factorial over n minus r factorial. It's just like the NCR, but it doesn't have the, it's missing a factorial on bottom. (22) shift NPR 3. My calculator actually shows a P or a C when I hit the button. 9,240 for what we had. 22P3 is 9,240. So this is a true story. Following is a true story. I live in Sacramento. Every year the state fair is at Cal Expo. All the little counties send their thing up to put on a show or a little thing. Cal Expo also has horse races. And when I was like, I don't know, 10 or 11, I was young. My cousin, she was like 30, lived with us, with my mom and me and my brother. And she took us to the fair one year, and this is a long time ago. My mom gave her like, this is like 40 years ago, this is how long ago this shit is. Around 40, it would maybe be 38, might be fucking. It's around 40. She gave my cousin Annette $20 for each of us to spend at the fair. $20 went a long way, it wasn't like one combo meal nowadays. You could bet on the trifecta at the horse races. My cousin wanted to show us the evil of gambling. The trifecta at horse racing. You have to pick first, second, and third. You say the name of the horse that's gonna take first, you say the name of the horse that's gonna take second, and you say the name of the horse that takes third. I wanna say there was 12 horses. There's usually 10 or 12. I don't remember exactly how many horses. I'm gonna say 12 horses. The main part of the story is free. There were 12 horses. It was like a $2 bet. It was not very much of the $20. There are 12 horses. I picked 3. Based on their names. I don't remember what their names are. I won. I was so fucking excited. I knew I won. I'm like, I knew that she said the trifecta. Like I saw the odds and I knew enough about math even at like 10 years old. Like I knew that $2 was gonna turn into like a couple hundred. I was fucking pleased as fuck. Did she give me any of that fucking money to spend at that fair? Hell fucking no. That bitch, and I don't like using that to describe women, but that was matter of shit at my cousin. She did, she went home and took that money to my mom, gave it to my mom. That defeated the entire purpose of showing us how gambling can cause you to lose money. And so she didn't let me have that money, but. I didn't get it, but what are the odds of getting that trifecta? Here, my N is 12, my R is 3. So the number of choices that are generated is 12p3. I'm gonna do it without the calculator. This is 12 factorial over 12 minus 3 factorial. Which is 12 factorial over 9 factorial. And I can break down the 12 into 12 times 11 times 10 times 9 factorial. I got a 9 factorial on bottom. Those cancel out. And 12 times 11 times 10 is 1,320. Yeah, I did that in my head. No, it's not as hard as it looks. When you multiply a number by 11. As long as it works pretty well. You put the two numbers to the side. And you add them in the middle. So 132. And then times 10. 1,320. So my probability of just picking numbers or picking horses by name. Probability of winning that trifecta. There was only one winning combination out of 1,320. I didn't have a very good chance of getting it. I don't think the trifecta pays 1,320 to 1. It's more like a couple hundred to 1 usually. Depending on what it is. It's a lot better than just picking a single horse to win. If you were literally picking second and third place. Oh, I actually wrote down the decimal on this, so I don't even need to grab a calculator. This is 0.000758. Or if I move the decimal right twice to go to a percentage, 0.0758%. Not even 0.1%. That is a very low chance of getting that. I was mad as shit.
How much did you win?
I don't remember, it was a long time ago, I know I didn't get it, and that's why I don't remember. And yeah, you know my mom didn't give that kind of money to a kid. 10-year-old don't need back then, that's like the equivalent of like. Your mom just giving you fucking $3,000 nowadays. It was fucking, no. That's mad. Or just come up in modern life. Then I relate this to something we know. Like, say. Winning the lotto. Go with Mega Millions, let's be specific. I'm gonna go Google how many balls were picked. I don't remember them. So I let it up to. What the hell, why did that not work? There you go. So I Google the Mega Millions, we're gonna click on the Mega Millions website. And it's actually gonna tell us what the actual odds are, but we're gonna calculate them. We wanna know how to play. So pick 5 numbers between 1 and 70. And 1 number between 1 and 25. So 1 and 70 for 5 numbers and 1 and 25 for the other. Alright, let me go back to the other camera. So 70 numbers. Pick 5. And 25 numbers. Pick 1. Well, one way to do it is just write down my choices, just like we did with the license plate. The first ball could be 70. Second ball could be 69. Different balls. One of the balls is already picked. Then just like the license plate. Pick 5 numbers, those are the number of options we have for the first 5 balls. And then the last one is a little bit different. It starts at 25 because there's 25 numbers. The order that the lotto balls are selected in, other than the Mega Million, doesn't matter, right? So this first part is 70 choose 5. In fact, that's how they say NCR. They say N choose R. If you were to read it out loud, NCR is N choose R. And this is effectively 25 choose 1. You will find that no matter what you put into a calculator, if you do NC1, you just get N. Which is that 25 right there. This is 70 factorial over 70 minus 5 factorial. Which is 65 on bottom. And if I wrote that as 70 times 69 times 68 times 67 times 66 times 65 factorial, we can see how this connects to what's above. Same thing as doing the license plate thing you did, choosing, writing down the number of options we had available and multiplying. So what is that? 70 choose 5 equals and then times 25. There are 302,575,350 combinations. For Mega Nuggets. The probability of winning. There's only one ticket that has, one combination that has it. Out of that number. It's giving me a negative exponent thing. Which means I gotta move that decimal, move it left 9 times. That's a really low number, right? Now. On Thursday, we'll start doing. This chapter 6, discrete random variables. And we're gonna talk about something that has expected value. And I'll bring this back up on expected value. There is a little more I wanna do in 5.5, but we're out of time. It's not much, I'll do it on Thursday. Have a good day, peace out, GTFO. It's also Taco Tuesday too. I love me some masala.
Go to Leo's right now.
Ross?
Yeah, I don't live too far from there, I had the first Toledo, I think it was the first Toledo's over in Hanford.
Yeah.
I fucking love the shit out of that place, yeah. They don't fuck around.
No, they're open 24 hours?
Yeah.
Yeah, I saw the
That's
lady there,
convenient right there.
Bro, like late at night when like 3 AM after a party. They get
Right. I wonder how busy it gets that way, I bet it gets pretty busy on a Friday.
Yeah, to go there.
I do, I love their tacos and shit, oh hell yeah.
Guys.
Peace,
Don't expect more from me this week, till Thursday.
that's okay, I don't expect a lot from you. Shots fired!
Fire back.
What?
You didn't even try to fire back.
No. He does it enough, he told me he hopes I shit my pants, right, I mean, what else can he say? Okay. Right at the end, Krista, I think I have 4 or 5 chapters left, I'm getting real close to the end. This close to starting Winding Tree. I might binge, I might tell my wife I ain't watching TV tonight. Just go finish listening to the audiobook, and that way I can start Winding Tree tomorrow.
These are like,
Slow. Have a good one.
when did you start reading them?
Back before like November.
So I didn't start till November.
It wasn't much before November,
Look at that.
and it's not the only thing I've been reading, like I went through all of Zen and Crawl. You have a good night too.
I'm also reading 2 other very songs from Pleasant School, so.
Why do you look at two other ones at the same time? So I didn't choose one.
What was the one I've been meaning to finish, the Skyward series? for a while, and I got the third and fourth one for my birthday and Christmas.
Nice.
So I had to reread them, first and second one.
How did those oversee Wind and Truth?
They don't. But they're easier to read when. Like, super.
I read the first one, I really liked the first one, and I started reading the second. And like 5 or 6 chapters in, I'm like, I'm just not feeling it. I think it was I was in the mood for something else. And I'm just gonna, oh, I gotta go back to it, cause I like the first book.
Yeah. I know, I don't think I ever finished the second one.
Oh, wow.
I think I got close and then I had to return to the library and then I got busy and just forgot about it.